Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Teguh Supriyanto. I am from Polytechnic Negeri Banjarmasin. In this time, I will present our research about designing a hybrid activated carbon kaolin catalyst for enhanced liquid fuel production from mixed plastic waste pyrolysis. This time, I would like to thank to Committee of Borobudur International Symposium 2025. Okay, this presentation explores the design of hybrid catalyst combining with activated carbon and kaolin to improve liquid fuel production from mixed plastic waste pyrolysis. And this is the big issue about the plastic waste to the energy, because the plastic in sometimes is our problems, and in other hand, is energy is also the problem in this decade. So we use plastic waste to make energy. The motivation of this study is to investigate whether a hybrid catalyst composed of activated carbon and kaolin can improve the efficiency and yield of liquid fuel produced from plastic waste pyrolysis. Okay, here I will show the literature review. Previous studies have highlighted the potential benefits of using activated carbon and kaolin as catalysts in pyrolysis processes. It is showing that improvement in fuel yield and the efficiency of the reaction can be uh, production to liquid fuel. This is the some papers that we just reviews in this study. We see that kaolin clay catalyst and as a catalyst is can improve the fuel stability and heating value of the uh, liquid products. It is also, we can show that mesoporous kaolin catalyst can high selectivity toward liquid hydrocarbons. And it is so that uh, activated carbon, and this in highlights, and polypropylene waste can yield that uh, about 20% at 400 Celsius, and it is fits with diesel fuel standards. And also some of the clays or minerals, it is can uh, yield about liquid products and comparable to the diesel fuels. And it is also our have comparison about some of the study. This is colored catalyst that use bentonite, kaolin, silica gel, and activated carbon. It is have a synergetic effect between activated charcoal and clay components. This is a very important uh, experiment that we comparable in our study. And also the various class types that have been conducted by Doroshenko et al. In 2022. These different clay types impact bio-oil quality. It is also important for us to use different clay, especially clay for South Kalimantan. And also this is from Kaset Sub Sin et al. This is using activated carbon, and the result is activated charcoal enhanced carbon conversion and efficiency. From this review, we will continuing our experiment to uh, mix about the kaolin and car activated carbon, so we can expecting more uh, uh, higher yield or higher quality about the liquid products. From the review, we can make some notes and patterns. Several studies that using kaolin report that liquid yield between 76 to 90%. It is depending on type of plastic mixture, catalyst loading, and a reactor temperature setting. It is also we can understand about the pyrolysis is so many factors that influence this result. And using activated carbon, especially from waste materials, appears promising at least one region in 2024 study so that improved quality liquid yield over non-catalytic pyrolysis. And also mixed catalyst system. This is activated charcoal, clay, and silica sometimes achieve high yield about the 87%, as suggests that synergy when combining different catalyst type. And also catalyst treatment and mesoporous impregnated with metal is to improve the kaolin so it can make a better zeolite. This is the special journal or special papers that we want to compare about because these papers using different catalysts from clays. This is in bentonite, kaolin, and bentonite is kaolin, and also silica gel, and the most important is they are also using activated charcoal as a catalyst. But in this research, difference from our proposed research that we are using in our experiment, we are using the activated carbon and a local catalyst kaolin from the South Kalimantan. So this is the research aim and hypothesis. The aim of this research is to evaluate the potential benefits of the using hybrid activated carbon kaolin catalyst in comparison to single catalyst, with the hypothesis that hybrid catalyst will yield higher quality liquid fuel. This is the properties of the activated carbons. Activated carbon have a special properties that support the activity in catalyst. And the first is offer extremely high surface area. This is more important properties of the activated carbon. And the second is they have abundant microporosity with oxygenated surface groups that act as absorption and radical stabilizing sites. In the third, these properties have been linked to enhance cracking of heavy tar traction and improve oil quality via deoxygenation and redistribution of heavy aromatics. Because activated carbon operates largely via absorption mediated radical pathway, it tends to favor liquid yield and reduce coke formation when applied in moderate loading. There is some special characteristic of the activated carbon that support in activity for catalyze. And we have a Kaolin from South Kalimantan. In South Kalimantan is have a large deposit of kaolin, so this can be potential to use this kaolin for catalyst. And this is some properties of the catalyst. This is rich of silica alumina. This provides active and acid sites to promote CC bond cracking, enhance conversion of long chain polymers into liquid field fractions. The surface acidity, this facilitates the depolymerization and cracking reactions, reduce tar and heavy oil formation, and improve selectivity toward gasoline-rich hydrocarbons. And of course, in this our area in South Kalimantan, it is evidence and low cost. And at this time, it is less in not in the value is still low. So we make a hypothesis from this our uh, study the synergy between activated carbon and kaolin as hybrid catalyst in plastic pyrolysis, the absorption and catalytic cracking. So this is very important in pyrolysis process is catalytic cracking. Activated carbon will trap long chain hydrocarbons. Kaolin performs CC bond cracking and isolation. So this is in our hypothesis, this is produce lighter hydrocarbon. Now, lighter than the not using a catalyst. The complementary pore structure, activated carbon in meso and micropores, less pore blockage. This is so this will be ACSS. Kaolin derived materials, the micropores. This is have a high selectivity for filtrants of compounds. And the third is co-reductions. Activated carbon distributes carbon and radicals. The radical is can reduce co formation. So this will be in have reduction in co-production. It is of course this is reduces coke formation and acidic sites. Improve product selectivity. The more gasolines or diesel-rich compounds, will be lower viscosity and are contained in liquid, so it is have a higher hiding value. So this is our expect or our hypothesis from this study. This is our experiment setup. It is we have a expect reactor. And this is the pyrolysis process. The material of this study include mixed plastic waste, such as a PET bottle or plastic bag. And so we are using, of course, activated carbon and kaolin as catalyst. The temperature that we are using is about 400 Celsius to break down mixed plastic waste to into liquid fuels. The characterization, we will using the SEM and XRD to determine the layer surface and surface area and properties. This is crucial evaluating their catalytic effectiveness. Now, of course, in the product, we will characterization by energy contents, viscosity, semiconductor composition to determine the quality of the liquid fuel produced. And it is also important to catalyst performance. We will compare about how the yield when we are using the catalyst and produce using the single or conventional catalyst. This is our expected outcomes. While the study has not been conducted, it is expected that the use of hybrid catalyst will result in higher liquid fuel yield and improve fuel quality, making the process more efficient and sustainability. Okay, this is the conclusion atau this study is aimed to provide insight into the effectiveness of hybrid activated carbon kaolin catalyst So it is very important to enhance production of liquid fuel from plastic waste. If successfully, this could be provide a valuable method for recycling plastic waste into renewable energy. So I hope the participants of the Borobudur internal session we can discuss about this catalyst. And of course, the future research direction is to explore optimization of the catalyst compositions, temperature condition, and reaction time to maximize fuel yield and quality. Okay, thank you very much. I think this is enough. And of course, we need your suggestion, your critics, and discussion from other researchers in Borobudur International Symposium. Thank you very much.